Previously, we looked at linear number patterns. That's the one we've been doing since grade 8. We not necessarily called it that in grade 8 and 9. We talked about a constant difference, okay, because it has a constant difference, but it's linear, straight line, right? Quadratic number patterns will be like a parabola then, okay? And instead of having a constant first difference, quadratic number patterns has a constant second difference. Okay, and what that actually means. Okay, just for good form, I'm labeling them, doesn't really matter. Okay, so if we look here, from 1 to 5, we're adding 4. Then from 5 to 12, we're adding 7. Then 10, and then 13. Okay, so this is not a constant difference. Okay, it's not linear. We can see that clearly those are not the same numbers. But quickly look at how much they differ by. If you just had this as your number pattern, you would have said the constant difference is 3, right? So, because that doesn't happen in your first difference, this is your first, but it actually happens in your second difference, that's what makes this quadratic. The second difference is constant. And then we can get into the nitty-gritty of like where it comes from. You don't have to know this whole table. What you need to know is the circled parts. I just said here your second difference is constant and your first difference forms a linear number pattern. That's important to remember. The general term will look like a parabola, and we'll get to this when we get to functions. This is one of our formulas we have for parabola this here, where we have an squared plus bn plus c. And this should look familiar to you because we have done the quadratic formula already, where we also use those letters, right? So then how to find a, b, and c is whatever you have, and you work from the bottom upwards. Whatever you have as your constant second difference, you equate to 2a. You solve for a. Then you work upwards. Whatever you have as your first difference, you equate to 3a plus b. You already solved a here, so you solve for b now. Then you use your a and your b that you already solved for. And a plus b plus c is equal to whatever your first term is. Okay, so that's what you need to remember. Okay, let's actually use that now. Okay, first important part is go find your first differences. And then once you have your first differences, you go find your second differences. Okay, and then if your second difference is constant, then you know it's quadratic. So now we know 2a is going to be equal to 4. 3a plus b is going to be equal to 5. And a plus b plus c is equal to 4. That's what I meant there earlier. And you work from the bottom upwards. This question wants us to find some 5. Okay. Let's quickly backtrack to that. Okay, we know this should be a plus 4. Then 13 plus 4 is 17. Okay, so in other words, from there to there, we have to add 17. So T5 will be 31 plus 17, which is 48. Okay, anyway, now nth term, the actual part we wanted to get to. Okay, you work from the bottom upwards. So 2a is equal to 4. Therefore, a divided by 2 is 2. Then 3a plus b is equal to 5. We've already solved a, so we go substitute in there. So now we have 6 plus b is 5. You go subtract the 6 to find b, so you get -1. And then a plus b plus c is 4. Okay, a you already have is 2, and b you already have is -1. So this gives you 1 plus c is 4. So c is 4 minus 1 is 3. So now you have your a, b, and your c, and you just go finish it off by putting everything together in an equation. So it's going to be 2n squared minus n, or you can say minus 1n plus 3. And then you're done. Okay, just keep in mind if they say they're a different letter, if they say find the kth term or whatever, then instead of n's you would have used k. That very rarely happens, but it could, and it has happened quite recently with the grade 12s actually. Okay, let's look at another example. Start off by finding your first differences and then your second differences. Then we know 2a is equal to -2. 3a plus b is equal to this -2. And a plus b plus c is equal to 18. Okay, work from bottom upwards. 2a is equal to negative 2. Okay, divide by 2, so a is negative 1. This is a negative forever. Anyway, then 3a plus b is equal to negative 2. We already have a, so we can substitute that. Okay, so b will be equal to, this is a negative 3, so we got plus it on the other side, or to get it to the other side. So this is 1. And then a plus b plus c is equal to 18. We substitute what we already have, which is negative 1 and 1. Okay, that's of course 0. So we know c is equal to 18. And then put everything together. Tn is equal to negative n squared, or negative 1n squared, plus 1n plus 18. Okay, then finding T15. They already tell you there 15 goes in n's place. So T15 is equal to, everywhere they put the n, you go put your brackets and you add 15 in there. And you just want to go put in your calculator. And you get your answer. And then which term in the sequence is equal to negative 72? So negative 72 is the answer, the Tn. So you say negative 72 is equal to negative n squared plus n plus 18. Okay, now you're going to have to solve for n here and it's quadratic. Okay, so factorization or the quadratic formula, whatever. Okay, so because this is a minus, I would take everything to this side. Doesn't really matter though. So n squared minus n minus 18 minus 72 equals 0. So I just changed all these signs so they can move to the other side. So you have n squared minus n minus 19 equal to 0. And then you can decide how you want to solve this, okay? But you should be getting two answers. You should be getting 10 and negative 9. But then, of course, with number patterns, we start by term 1. That's the smallest possible term. So you can't have a negative term. So that is not applicable. Our answer is just 10. Okay, remember to say or indicate that it's not applicable by either putting a stripe through it or saying NA or whatever. No.